Hello, ladies and gentlemen. In this video, we're going to talk about something that most of you are probably already familiar with. We're going to be talking about two-dimensional areas. Odds are you've already covered this in a previous years of math, so why would we talk about it today in 8th grade? Well, because our goal is to take two-dimensional areas and use them to find these things called three-dimensional areas. And maybe by using the words two-dimension and three-dimension, it's going right over your head. Mr. Grapp, I have no idea what you're talking about. All I know is it was called area. Why are you calling it two-dimensional area or three-dimensional area? Or maybe you don't even know what area is. So let's start with the basics. We're going to review it. If you already know it, great. If you don't, sit tight. It's going to make sense by the end of this video. I promise you. Let's start with the very basics. Area is only in something, it's a two-dimensional distance. Now, two dimensions means that it has two types of distances. For example, this is a square, right? Or well, this is a rectangle, actually. This is a rectangle, and it is called a two-dimensional shape. And the reason for that is because it's got a horizontal distance. That's one dimension, horizontal. And it's got a vertical distance. The horizontal distance, we call that the base. The vertical distance, we call that the height. And together, they make a two-dimensional shape. Two dimensions, two-dimensional. Area is the combined distances put together. It's the inside value of the shape. And it is a two-dimensional distance because it incorporates both base and height, horizontal and vertical. It's called a two-dimensional distance because it incorporates two dimensions. Just a quick peek in the future. In the future, we're going to add a third dimension, a horizontal, a vertical, and then a dimension called depth. And that is this imaginary dimension that goes out past the shape into this imaginary plane of the outside world. It's what you're used to seeing in real life. 3 dimensions. Imagine that this was actually more of what you might call a cube or a prism. That's coming up in the future. But today, let's just stick with 2 dimensions. No sense getting it overcomplicated before we're ready. Start simple, then we get complex. So the unfortunate truth is that these formulas for finding this two-dimensional distance called area, this two-dimensional value called area, unfortunately, there's only one way to know that, and it is through these formulas. There's no really cool, intuitive, mathematical way to find each of these formulas. It really comes down to actually memorizing them. So if you want to find the area of a rectangle or a triangle or a circle or any other shape, you really just have to sit down and memorize its associated formula. Luckily, they're usually pretty easy to memorize. It just can get kind of confusing when there's a lot of them. So if you don't already know these formulas, my advice to you is to pause the video and then cover them up with your hand and then try and see if you can quiz yourself until you get them right with at least 90% accuracy. You'll develop this more and more as you work with them. But really, I encourage you, by the end of this, at least memorize these 3 formulas. Okay, so let's start trying to find some areas, some two-dimensional areas. As mentioned before, this is a rectangle, a triangle, and a circle. The rectangle is a very easy formula. We're just going to multiply the base times the height. The base is the horizontal dimension. It's that horizontal distance. That's the base. And the height is the vertical dimension. Now, something to notice, the height is always, whether it's a rectangle, a triangle, a trapezoid, whatever shape you're working with, the height is always perpendicular to the base, meaning it always is 90 degrees in relation to the base. Just know that now. The base and the height must be at 90-degree angles. Okay. The rectangle, very simple. Base times height. So let's say hypothetically this was, that wouldn't make sense to be 3. Let's make this 4 centimeters. The base is 4 centimeters. And we'll make the height 3 centimeters, all right? What would the area of this shape be? Well, we're going to start by writing the formula. We always start with the formula. Area is equal to base times height. Then I'll plug in my base and my height. So the area would be equal to base 4 times height, 3. And then I would solve it. What's 4 times 3? 12. 12, and remember we're working with centimeters. And maybe you were confused. Maybe back then you were like, Mr. Grab, isn't it centimeters squared? And you're right, it is centimeters squared. But why is it squared? Well, let's think about that. There's 2 ways to come to that conclusion. One, what kind of dimension are we working in? Are we working in 1 dimension, 2 dimensions, 3 dimensions? We're working in 2 dimensions, base times height, 2 squared. Or you can think about it as this. Let's say I kept those little indications in there. 4 times 3 centimeters. Well, 4 times 3 is 12. What's centimeters times centimeters? Well, isn't that just going to be anything times itself is just itself squared? Centimeters squared. So 2 ways to understand why do we square the distances. One reason is because we multiplied them together. The other reason is we're working in 2 dimensions, so the square, 2. Okay, base times height, rectangle, super easy. Don't overcomplicate it. All right? All this is just extra frills. Just remember, area of a rectangle, base times height. 4 times 3, 12 centimeters squared. Bamskis. What about the triangle? Well, the base is pretty easy to spot. It's this horizontal distance, right? Base is the horizontal distance. But which one of these is going to be the height? Is it going to be this one? Is it going to be this one? Well, let's look. Do any of these have a 90-degree relationship to the base? Are they perpendicular to the base? Well, if I'm looking here, these don't look like 90-degree angles. So actually, neither one of them is the height. Well, then where's the height, Mr. Grab? The height will be a line that is perpendicular to the base that goes through or goes and points up to the opposite vertex. Vertex is just a fancy word for the opposite point on the triangle. This would be the height. It is the imaginary line from the base to the vertex that is perpendicular, 90-degree angle. So let's say that this was, let's use the same numbers. Let's say this is 4, and we'll go inches, and let's say this was 3 inches, hypothetically. We're just going to plug it into this formula up here. Base times height divided by 2. Okay, so I'll write the formula because we always start with the formula. Area equals base times height divided by 2. I'm going to plug it in. My base is 3. No, my base is 4. I want that in green. My height is 3, so it'll be 4 times 3 divided by 2. Meaning the area would be 12 divided by 2, or 6. 6 inches. And how many dimensions are we working with? Base and height? 2 dimensions. There we go. I'll box this one as well. So once again, area is very simple. You just have the formula, you plug in your measurements, and you go. You just write it out. All right, last one. What about circles? What's the area of a circle? Well, the area formula is pi r squared. And remember, this isn't just pi with the number r squared. It's pi times r squared. When we have a little variable there, it's multiplication. So pi r squared. Important piece of information if you don't already know. Pi is an irrational number. It goes on forever. But for our purposes, we're just going to say it's about 3.14. In high school or college, you might extend it 3.14159, et cetera, et cetera. But for middle school, 3.14 is a good place to keep it. Okay, that explains pi, but what's the radius, Mr. Grab? Well, there really isn't a flat edge to measure on this circle, is there? There's no flat edge that I could call the radius or the height or the base. So we have to make our own, and it's called the radius. The radius is the distance from the center of the circle to any point on its outside. So like that. That would be called the radius. It's the distance from the center to the outside of the circle. So let's try this one out. let's say the radius of this circle was 5 miles. It's a very big circle, okay, huge circle, 5 miles. The area formula, again, we start there. Area equals pi times radius squared. I'm going to plug in my numbers. Pi was 3.14 times the radius, which is 5. And I'm going to square it, so 5 squared. And then I'll just simplify and solve. Area would be 3.14 times, what's 5 squared? 25. And then what is 3.14 times 25? I don't know. Let's get a calculator. 3.14 times 25, 78.5. About. Again, this is roughly because we didn't use the whole thing of pi, but 78.5. So I guess we would have to put a little, this is almost, approximately 78.5 miles. And remember, are we doing a one-dimensional or a two-dimensional distance? We're doing two dimensionals, so miles squared. All right, that's our little quick review on area formulas. Again, distill it down to its simplest parts. Here we go. Bullet points are this. Area formulas are the little equations that we use to find the insides of two-dimensional shapes. To find the area, you use the formula, plug in the base and the height, and solve. Or plug in the radius and the pi and solve. Remember that the height must be perpendicular to the base. Okay, distilled bullet points, there you go. In the next video, we're just going to practice. We're going to use these to find some areas. So I'll see you there.